Hello, 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 hello. Good evening, good evening, good evening. Good evening to all of you. Am I audible and visible to all of you? Hello, 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 hello. Okay, so I guess I'm audible and visible to all of you, right? So as of now, we completed couple of chapters from 11th physics. Now from today onwards, we will be starting NLM, laws of motion, and also one more thing that from tomorrow morning, I am starting a series of 12th physics, but that series will be in English. Okay, so I will tell these lines in English also. So basically, कल से मैं एक सीरीज स्टार्ट कर रहा हूँ 12th क्लास की, जो बहुत बेसिक से होगी आपके एग्जामिनेशन 2026 के लिए, चाहे वो नीट के लिए प्रिपेयर कर रहे हो, जेई के लिए, बोर्ड्स के लिए. 3 मंथ्स में मैं सिलेबस कंप्लीट कर रहा हूँ. Within 3 months only, right? I am completing all the syllabus. So from tomorrow onwards, I will be starting 2 sessions per day. Morning session for English students, that means Hindi students, and the evening session that will be for 11th students and English one. Good evening, beta. We have good evening. Okay. And in the meantime, I am starting a couple of series for your NCRT's backlogs, for your PYQs, and most important numericals for your upcoming examinations. So, but slowly, we will just going to add these sessions, right? But as of now, we will be having only 2 sessions per day: morning session and evening session. Morning for 12th English, because as you know that for English students, I just completed the whole 12th, right? Except for two chapters, and for evening one English 11th. Okay. And as you know that I will be starting a paid batch also. So if you are interested in my paid batch in one-to-one interaction classes, there you will be asking me doubts in a live mode, right? Zoom class like that thing, right? So you can just ping me a comment, or you can just go to my Telegram channel. There you can just connect with me personally, and we will be sharing the all these things there. Okay, details. So I guess we discussed each and everything for today's class. Now let us start with the content now. Okay, so we are good to go. Okay, so if you want to ask me anything now, so you are most welcome in the comment section, without abusive language, without any disrespectful things, right? So if you want to ask me anything, you're most welcome. Okay, I hope my board is visible to you. So okay, so let's start now. The very first thing that we will be starting here, that will be first law, NLM, right? First thing that we will start in NLM, that is your Newton's first law of motion. So I will write here Newton's first law of motion. I hope you are very well aware of this law from your 9th standard. Okay. What the first law states is that this law is also known as, I will write one more name for this law, that is Galileo's law of inertia. Okay, I will write here, also known as Galileo's law of inertia. If you open your NCERT, you will find first section as Galileo's law. Then you will find Newton's law from the Galileo's law. These are names to the one only statement. That is, if a body is at rest, if a body is at rest or moving with constant velocity, then or constant motion. If a body is at rest or moving with uniform motion, means constant motion, it will continue its state. A body will continue its state until and unless affected by any unbalanced external force. Okay, I will write the statement. First of all, you need to understand it. If a body is at rest or if a body is moving in uniform motion, a body will continue its state of motion or state of rest until unless it gets affected by unbalanced external force. There should be unbalanced external force. Okay, now I will write the statement here that every body, if you want to write, you need to write it, right? Every body continues its state of rest or uniform motion. In the back chapters, we defined what uniform motion means, right? Uniform motion simply indicates where velocity is constant. I will write where my velocity vector is constant. And velocity will be constant only if the magnitude of the motion and the direction of motion is same. Every body continues its state of rest or uniform motion in a straight line. In a ST means straight line until and unless compelled or affected by an unbalanced external force. Unbalanced external force to change in its state. To change in its state. Done? So Newton's first law states that if a body is at rest or going with uniform motion in a straight line, it will be in its own state unless gets compelled by any external unbalanced force. Okay? Do you know what is the meaning of unbalanced external force? The meaning is, look, let us suppose we are having something like that. Look. This is my body with mass m and the body is at rest. Now I am applying the force, but my net force is zero. And the body is at rest. This state is known as static equilibrium. Static equilibrium. Or look now, one more. If a body with mass m, it is going with uniform motion. Okay, and still my F net, F0 or F net 0, both are two different entities, right? If my F net is 0, so this state is known as dynamic equilibrium. Okay, so you can write like this, na? If a body is at syncretic equilibrium or dynamic equilibrium, it will be in its state until and unless F net, there will be a change in F net. Then, if let us suppose now, look now, you can see from here, my F net, na, you can see from here, look, my F net is 0. You can see my F net is 0. You can also see here my F net is 0. If my F net is 0, so no change in its state. No change in its state. Now, if my question is, if my f net is not 0. Now, my question is, if my f net is not 0, then what will happen? Okay, I will write, if my f net is not equals to 0, then what will happen? Okay, I guess you know it now. I guess you know it. If my f net is not 0, what will happen then? Done? Look. So first of all, what it will change? So I can write, sir, it may change. If my f naught is not 0, so it may change the speed of the body. The speed of the body. How? We know from the kinematics that if the direction of my force and the direction of my velocity or the motion is same, so this is speed uppercase. If my direction of the body going and direction of my force applied is opposite, you will write speed down. Okay, just like now we are accelerating our car. Accelerating means we are just pushing the accelerator pedal, right? So my velocity or my speed of the car increases. Now if I apply the brake means opposite motion, my velocity or my motion decreases. Second part, it may change direction. It may change direction. It may change the direction of the motion. The direction of motion. How, sir? If my body is going in this and we are applying force with some angle, so there will be change in this motion, just like projectile motion. Okay. The third, it may change both. It may change both. Both means it may change speed and it will change my direction. How? Look, if this angle theta, so just take it as component form. Look, this would be f cos theta and this could be f sin theta. Perpendicular is responsible for direction change and this one is responsible for magnitude change. Now one more, it is then 4. 4 is it may change size of the body. Size of body. How? Look, we are having a rod. This is my rod, right? Now I am applying forces here. I am applying forces. Okay, then what will happen? The rod will become a thinner rod. So you can change. Now look, this is L. This is L plus delta L. You can see here change in its length. So all of these. Hello, beta. Now all of these are the what? Properties or the results of if my f net is equals to 0. If my f net is 0, so these 4 possibilities are there. Done? As you know that this is our first class of NLM. That's why I am going it slowly, right? After getting the basic things done, then we will be very speeding up. Okay, and this chapter will take 1 week time to get completed. Then we'll be starting circular motion, WP, right? Look now. I guess I am not going very fast, right? Now, I hope I am not getting very fast. I'm just teaching you each and everything in a very detailed manner, right? Look, if I am going very fast now, you can tell me. If you don't have time to note down these things, right? At the end of my chapter ending, I am just forwarding these notes to the Telegram group. Everything that I'm just writing on the screen now, these slides I am sharing in my Telegram group, right? Okay. If you want these notes, you can just join my Telegram group. You will get these notes. Okay, now as up to now, we are done with first law of inertia also. Now, basically, if you want to change the state, I will write here one statement, right? If you want to change the state of body, you need something. Okay, you need something. Walaikum assalam, beta. Look, if you need to change the state of the body, you need something. Okay, and this something is known as force. This something is known as force. What is force? Okay, you can tell force is something that we need to change the state of any body. If the body is at rest, and if I need or if I want to change the state of rest into motion, I need to apply force. If a body is going in uniform motion, I need to change this uniform motion in non-uniform motion. I need to apply the force, right? So force means a factor. Force is a factor which is responsible for the change of the state of any body. Done? So you can write one thing now, that first law, my first law of motion, it is related to force. First law is related to force. That means we are discussing the force only. If my force is 0, no effect. If there will be a multiple effects, right? It will change the magnitude of motion. It will change the direction of motion. It can change both these things. It can change the shape of the size of the body. That is why we are having a big balloon. We are compressing the balloon. Its shape will be very small. It gets compressed. It is also a factor of F net is not equal to 0. Okay. Now what we are having now units of force. We need to deal now units for measurement of force. Units for measurement of force. Okay, so the very first thing where from we are deriving each and everything now, that is, look, F is equals to mass into acceleration. Later on we will be discussing this law now, but here just take one thing now, that force is equals to mass into acceleration. Now we are having two systems of unit. Now we are having two systems of unit. One is CGS, one is MKS also, or SI. Okay, MKS and SI is same. SI is a upgraded form of MKS. Now we are having three types, right? CGS, FPS, MKS. SI gets from MKS. In CGS, my mass is calculated in grams. Grams, right? What is acceleration? Acceleration is equals to velocity by time. Okay, velocity is my displacement or time square. So this displacement or distance in SI system is centimeter. So I will write here centimeter. Second is time is second square. Or I can write in dyne, D-Y-N-E, dyne. So in CGS, we are calculating force in dynes. Now in MKS, mass in kilograms, length in meters, time in second squares, also known as Newton. Also known as Newton. Done? So F equals to MA in CGS, gram, centimeter per second square or dyne. In MKS, it is kilogram, meter per second square or newtons. One more thing that you all should know, that my 1 Newton is equals to 10 to the power 5 dyne. If you need proof, you need to see the units and dimensions chapter. units and dimensions. For proof, right? Aritra Dara, beta, I didn't get you, na. DC Pandey Karayato Ho. I didn't get your point, right? But I guess you want to ask, you want to tell me that are you going to teach a DC Pandey numericals, right? So the answer is, in my coming days, I will be starting a series most important numericals for your NEET. In that series, basically, I'm going to collect all the most important numericals from your DC Pandey, your SC Verma, your Singhage, all the numericals for your NEET and JEE, right? So there you can just get all your numericals. Okay. If I will ask you, what will be the dimensional formula of it? What will be a dimensional formula? What will be a dimensional formula? What will be a dimensional formula of force? Force, right? So can I write as force is equals to my distance? Sorry, it is m into a. So 1 second. I will write each and everything, right? So is equals to m into a. So dimensional formula of m and dimensional formula of a. M is m only. So I can write m power 1. A is v by t. A is v by t. Okay. I can write m1. What is v? Is it s by t square? So I can write s by t. It will be s by t square. Okay. So what is m? M is mass, that is m1. S means length, it will be L1. T minus 2. When t will go upper side, it will become minus 2. So the dimensional formula of force is MLT minus 2. It is MLT minus 2. Now we are done with the units of force also and dimensional formula. But you will find a couple of numericals, just like the apparent weight topic things, right? Apparent weight, mechanical advantages, lift cases. There you also will find the force, but the units will be kilogram weight, kilogram force, gram weight, gram force. That means now here we are having some practical units. So we are having some practical units, also known as gravitational units. Gravitational units of force. I guess I am not going too fast, and I guess I am giving you all these things, right? Now we are having some practical units, we are having some gravitational units. And if you are very good with recapping things, so these things we had done in improper units. Improper units from units and dimensions. Done? So we are having 1 kilogram weight, 1 kg WT. This is weight. 1 kilogram weight. It is equals to 9.8 Newton, or approximately equals to 10 Newton. We are having 1 gram weight. 1 gram weight. It is equals to 980 dyne, or approximately 1000 dyne. Or we are having 1 kilogram force. 1 kilogram force. It is 9.8 Newton, or approximately 10 Newton. We are having 1 gram force. 1 gram force is 980 Newton, or 1000, sorry, dyne. Sorry, beta. Okay. Dyne or 1000 dyne. Okay. So you will find numericals based on this, definitely. if you're doing some good books, no, you will find numericals based on this only. I guess you have done some numericals, right? Find the weight of something, so the reading will be in kilogram weight. If you want to reading now, reading will be reading of your apparent weight machine, right? That is only in kilogram weight. It is very easy, right? It's not that much of confusing things, right? Now we will start now inertia. We will start now inertia. Do you know what is inertia? Do you know what is inertia? Huh? What is inertia? Inertia simply means if a body is at rest or if a body is in uniform motion, and if we want to change in its state and we applied an external unbalanced force, then before changing its state, a body will resist it. It is a natural phenomena. It will oppose the change in its state. That opposition is known as inertia. Is known as inertia. Just like we are having two bodies, right? We are having two bodies. If I am pushing the upper body, okay, that means we are disturbing in its state. So the lower body tries to get it back. This thing is known as what? A friction. In the same way, let us suppose we are pushing a car. Car is at rest. Now we are pushing this car. We want to change the state of this rest car. So the car opposes the change. That opposition is inertia. Yes. So this opposition means inertia. So I will write the definition, then I will just explain once again, right? So inertia simply means the property. Inertia is the property. The property of a body. The property of a body due to which it opposes any change in its state. Any change in its state. Okay. Inertia means the property of a body due to which it opposes any change in its state. Okay. Look now. If I am having a cycle, right? A cycle. And I am having a truck. A cycle and a truck. Both are at rest. Now look beta. I want to change the rest thing into motion. I want to change its state, rest to motion. What I need to do here? Sir, I will push both these things. Force F1, then I will force F2. Okay. We are having two bodies. One is cycle, one is a bus. Both are at rest. Now I am pushing both these bodies. So that I want to change the state of rest in motion. Okay. Could you just tell me which one will be more, F1 or F2? Which one will be more, F1, F2, or both will be equal? I want to answer from your end. Which one is correct option? Option number 1, option number 2, option number 3. Which one will be a correct option for these things? Okay. Which one will be a correct option from your end? Option 1, option 2, option 3. That simply indicates where I need to push some extra efforts to change the state. Cycle or a truck? Better, I need an answer from your end. No? If you understood the situation, you can give me the answer. Okay. Option number second, Ria and Avsina. They are giving me answer option number second. Okay. Option number second means my this option, right? This one. F1 should be less than F2. F1 should be less than F2. Why my F1 is less than F2? Because when we try to change the state, there is an opposition. There is opposition, and practically we know that more the heavier body, more is opposition. We know it practically. That means we got one thing. More the heavier, more the opposition. More the heavier, more is opposition. So you can write here, more the mass, more the opposition. Okay. More the mass, more is opposition. Okay, so you can write here, more mass, more opposition. So can you simply indicate that what is mass? Mass is measurement or measure of inertia. Measure of inertia. So you can write here, inertia is proportional to mass. More mass, more inertia. Mass is not inertia. Look beta, mass is not inertia, but mass is a factor which gives us idea which body will have more inertia and which body will have less inertia. More mass, more inertia. Less mass, less inertia. But mass is not inertia. Mass is a factor. Okay, now we are having types of inertia. We are having types of inertia. Types of inertia. So first of all, we are having inertia of rest. Inertia of rest. Inertia of rest. Inertia of rest. Okay. What does inertia of rest means? Inertia of rest means it is an inability of a body. Inability of a body to change in its state. To change its state by its own. I will give the example. Suppose we are in the bus. We are in the bus, right? So we are here standing inside the bus. And the bus suddenly starts. Suddenly. Bus suddenly starts. What this person feels then? Okay. What this person feels then? Look now. This person will feel a motion backwards. This person will feel a motion backwards. Why, sir? Look now. When the bus is at rest, first case, when the bus was at rest, so the person was also at rest. The person was also at rest. When the bus suddenly starts, the foot or these feet, right? They go with the motion. These pairs of foot, they go with the motion. But my upper body is not ready. But my upper body is not ready for this change. So my body want to be in its previous state. So it will go beyond. Okay, it will go like this, right? Look, we are standing like this now. You can see me, right? Let's suppose I am in the bus. Look, I am at rest. When the bus suddenly starts, my lower body part came into the motion just because of the contact of my feet and the body's plate. It will go with the motion, but my upper body want to be in its previous state. So it will go like this behind the bus. So this position known as inertia of rest. This thing is known as inertia of rest. Now second example. Second one or second part. Second part is inertia of motion. Inertia of motion. What is inertia of motion? I will take the same example. I will take the same example. The bus example. I will take the same bus example, right? Here, I am giving you practical examples. Now my body is here. Body is going with uniform motion. Body is going with uniform motion. Okay. Now the driver suddenly apply brakes. Now the driver suddenly apply brakes. What this particular person feels? This person will feel a motion in the direction of the bus. Why, sir? Look now. When the bus is going with, let us about 20 km per hour speed, the person which is inside the bus, it is also going with the same speed. That means attaching path is going with 20 meter speed. Okay, the body is going with same speed. Now, when the driver apply brake, the body will retard. The body will retard. Retard means opposition. It will go opposite to its motion. But the lower part now my lower part of the body will be in retarded motion, but my upper body wants to be in a previous state. So it will fall in front of the bus, right? So this particular thing is known as inertia of motion. If I am standing, I am at rest. If is there any change to my state of rest, I will go opposite to that state. Lower part goes like this in front, I will go backwards. Now if I am in the motion, in uniform motion, bus suddenly brakes. Okay, my lower part will be in same state, but my upper body, that will change in its state. That means the upper body will resist. It want to go like beyond, like these things. Now third example, that is inertia of direction. These are practical examples, right? Third one, it is inertia of direction. Inertia of direction. I will take same example. I will take same example. Okay. Now I will take different view now. If this is my seat, if this is my seat now, okay, a person is standing like this. A person is standing like this, straightwise. Now this bus turns sharp turn. This bus take sharp turn. Okay. Now the bus will go in this way. But my body want to be straight, no? The body want to be straight. Now my seat will be in a different way now. Okay. So that's why now let's suppose my seat will be in this way now. Okay. It will go tilt. It will go somehow tilt. Okay. So how my body will behave? My body will resist this change and my body want to be straight. That's why you are feeling an outward push. That's why you are feeling an outward push. Okay, if the body is going in this way, you are feeling like this. If a car is going in this way, you are feeling like this. Why? Because you want to maintain the posture of your body. And this thing is known as inertia of direction. This thing is known as inertia of direction. Don't worry, you don't get any numerical on this inertia topic. Nothing, you don't get nothing, na. But you need to understand what is inertia is all about. You need to get this thing done, right? But nothing you will get in the examination, right? Don't worry about anything. But it is given in NCERT in this detailed manner. That's why I'm just teaching you these things, right? But you won't find anything related to the inertia in your numericals. Yes. Have you seen that? Yes, beta. Yes, beta. Okay. Now, next topic is momentum. So, the next topic is momentum. What is momentum? What is momentum? Momentum, I will give you an example of momentum. I will give you an example of momentum. Let's suppose we are having a bus. We are having a bus, right? Suppose this is my bus. And we are having a car or a cycle. We are having a cycle. This is my cycle. Both bus and cycle moving with speed 5 kilometer per hour. Both moving with speed 5 kilometer per hour, right? Now I will be placing here a person before a bus and before a cycle. What will happen to the person A and what will happen to the person B? Who will get more hurt? Who will get more hurt? Who will get more hurt? Person A or person B? Person number A gets hit by a bus. Person B gets hit by a cycle with the same speed. Who will get more hurt by this strike? Person A or person B? Okay, person A. Why person A? Look, the answer is sir, more mass. More mass. Okay, more mass means more motion. More mass means more motion. More mass means more motion. That's meaning. So there is a one more parameter, that is momentum transfer, no? But I'm not getting into that thing. But here you need to understand that if a body is moving, so it carries some motion. So it carries some motion. That quantity of motion is known as momentum. So what is momentum? So you were right here. Momentum means it is quantity. Momentum is what? It is quantity of motion. So it is momentum means quantity of motion. And these are examples. These two things are examples. Yes, beta. So momentum simply indicates quantity of motion. More quantity of motion, it will have more impact on the body. Okay. But what is momentum numerically, or what is momentum by equation? It is product of, momentum is product of mass and velocity. Product of mass and velocity. Product of mass and velocity. And momentum is a vector quantity. And momentum is a vector quantity. Okay. And if you want to take the direction, direction is along instantaneous velocity. Okay, so if you need to now write the formula of it, so you will write in a way that momentum is P, momentum is equals to mass into velocity. Momentum is nothing, it is mass into velocity. This equation. Momentum is what? Mass into velocity. Now rest things you can find by your own. No? How? What will be it is SI unit? What will be it is SI unit? So mass is kg and velocity is meter per second. So it is SI unit will be kilogram meter per second. And if somebody will ask you what will be the dimensional formula, what is it is dimensional formula? So what is kilogram? Kilogram is m. What is m? Meter. Meter means L. T. So I can write T minus 1. Dimensional formula. The dimensional formula. Okay, what is the meaning of instantaneous velocity? The meaning is, look now, what is the meaning of it? Look, if we are having a curved surface, this is my curved surface, and body is going in this way. So look now, what will be the direction of momentum? Look, at this particular point, first of all, what will be the velocity direction? You need to take the tangent. So this tangent will be giving you the velocity direction. And along this velocity, you will be having your momentum direction. This is the meaning of it. This is the meaning of direction is along the instantaneous velocity. Yeah, at a particular instant of time. Yes, beta. Now, if you understood up to this particular point, and if you know vectors, now let us start numericals. Slow. Okay, let us do a numerical now. Okay, numerical is a block of mass 5 kg moving with velocity. Velocity is given in vector form as I cap plus 2j cap plus k cap meter per second. Find the momentum. Find the momentum. Okay. So I will give you, let us suppose, 2 minutes to finish this numerical. So we are having a block, and block is carrying a mass 5 kg. This block is moving with velocity I cap plus 2j cap plus k cap, that means vector form. Find the momentum. Okay, so I will write here, find momentum, P vector, and second part, P vector magnitude. Find these two things. So I am just providing you 2 minutes. I will be giving you 2 minutes here, right? There is a timer also. 1 second. Timer is somewhere, right? Okay. Do it now. Take your time, 2 minutes. Okay, someone give me 5 I cap plus 10 j cap plus 5 k cap. Okay, and what is the mode of it? $20. Okay, the mode of 5 square plus 10 square plus 5 square is 20 beta. Okay, look now. What is momentum? I guess momentum is very crystal clear to you. That is mass into velocity. Mass is 5 kilogram. Velocity is I cap plus 2 j cap plus k cap, which came out to be 5 I cap plus 5 to the 10 j cap plus 5 k cap. Now, if you want to take it as magnitude, you want to write 5 square plus 10 square plus 5 square root. 5, 5, 25. It is 100 plus 25. I guess my answer is 150. Done? Root 150 and kilogram meter per second. If you want to number in your board examination, you need to write this thing, right? For boards, the unit one is very important. Done? Okay. Yes, beta. One more numerical. Check for both balls having same momentum or not. You need to check whether this ball is having same momentum or not. Do this one. Check for both balls. Are these balls having same momentum? Yes or no? Are these balls having same momentum? Yes or no? Yes or no, beta? No. Why? Look, if I will calculate the momentum of ball A, it will be m into v. M is 2 kg. It is 10. It will be 20 kilogram meters per second, but it will be in j cap. Momentum of this one, P of B, it will be 20 kilogram meter per second, but in plus I cap. Now look, this momentum is in j cap and this one is in I cap. So you can write momentum of A is not equals to momentum of B, but magnitude of momentum of A is equals to magnitude of momentum of B. Yes? Done, beta? Okay. So now let us start change in momentum topic. Okay? Change in momentum. Change in momentum. Mod is same, yes. Magnitude is same. Now change in momentum. First case, if we are having some wall like this, okay, towards the, we are throwing a ball with mass m, it strikes the surface and this ball rebounds rebounds the surface with same velocity or speed. Find change in momentum. How to find change in momentum? Change means, if you want to write change means final minus initial. Final minus initial. Okay. Write momentum of final. Look, this is final now. Final, this one is initial. Momentum of this one. Momentum of final. Is it mv? But in minus I cap. Okay. What is momentum of first case, initial? Momentum of initial. Is it mv in plus I cap? What will be delta p? Delta p means change in momentum. It is momentum final minus momentum initial. Finally, momentum is minus mv I cap minus, sorry, mv is here. It is mv I cap. So I guess my answer is minus 2 mv I cap. If you want to write it as mod, so just write 2 mv. Just write 2 mv. Okay. If you are just throwing something and it is coming back with the same speed, this is case, right? So what will be delta momentum, or what will be change in momentum? 2 times mass into velocity in a mod term. Yes, it is not minus 2 mv. Minus means direction. You can write like this now. Look, 2 mv minus I cap. Okay, it is 2 mv only. 2 mv only. Minus simply indicates direction. We are not dealing with direction now. In mod case, we are not dealing with direction. That's why I am not taking minus here. Okay. One more case. If we are having something like this now, look. Something like this. Okay. And we throw something. Like this. Okay. Okay. Yes, in vector forms, minus will be there. We are having a ball with mass m, speed v. It rebounds the surface with same speed, and it is making angle theta with the horizontal. That means you are throwing a ball towards the wall. With mass m and velocity v. It makes some angle theta with the horizontal. It gets rebounded with the same angle, with the same velocity. What will be change in momentum? If you want to encounter a numerical based on this thing, what you need to do, look beta here. I will break down this. If this one is theta, so this is theta, because theta should be always with tail of vector. So this is v. If this one is v, so this will be v cos theta, or you can write mv cos theta in plus I cap. And this one is momentum. This will be mv sin theta in minus j cap. Okay. In this one now, look. One like this, one like this. This will be mv sin theta but minus j direction. This could be mv cos theta minus I direction. So what is momentum initial? Initially momentum is mv cos theta plus I cap plus mv sin theta minus j cap. Final momentum is mv cos theta minus I cap plus mv sin theta minus j cap. And change in momentum, what is change in momentum, beta? So I can write here, sir, my change in momentum means final momentum minus initial momentum. Finally, I can write minus mv cos theta I cap minus mv sin theta j cap, then minus mv cos theta I cap, then plus mv sin theta j cap. Look, mv cos theta, mv cos theta. So I can write minus 2 mv cos theta I cap. Cancel out. So momentum change in this case is minus 2 mv cos theta I cap, or if you want to write it as magnitude, that is 2 mv cos theta only. That is 2 mv cos theta only and only. Okay. First case is going horizontal, coming back horizontal. Second case, making some angle theta with the horizontal. So it is 2 mv cos theta. Horizontal means H, C. So you can write HC Verma, right? Horizontal C component, 2 mv cos theta. Now, third case. Now, third case. Third case simply means this is my wall. My ball is getting rebounded by this wall. I will make firstly these diagrams. Okay, look now. Ball with mass m, velocity v. Mass m, velocity v. Now the angle is with vertical. Now the angle is with vertical. Okay. Now my angle is with vertical. Now change delta, find delta p. Find delta p. Same procedure, same. Theta, theta. This would be mv sin theta I cap. This one would be mv cos theta minus j cap. These two. This would be mv cos theta minus j cap. It should be mv sin theta minus I cap. Now delta p. Final momentum minus initial momentum. Final is what? It is minus mv cos theta j cap minus mv sin theta I cap, then minus plus mv cos theta j cap minus mv sin theta I cap. So look, this one gets cancelled out. So my delta p came here, minus 2 mv sin theta I cap, or delta p mod, it is equals to 2 mv sin theta. Okay. Okay, so let us do a numerical, then tata bye bye for the class. So numerical is like fluid mechanics. Let's say we are doing NLM and then WP COM station after I guess 1 month. After 1 month beta. Okay, now look. A particle having mass m is projected with speed u at an angle theta from ground. Theta from ground. Calculate change in momentum between initial and highest point. Okay, do this numerical. This numerical is a combination of change in momentum and the H matrix concept of projectile motion. Combination of two topics. I will make the diagram of it. Then you need to think about how to solve this one. Okay, do this one now. Done. I will give 2 minutes, then I will just start doing it, right? Mu sine theta. Look now. Look here. There will be a u in two directions of the ball with mass m. Okay, so I can write here. So this will be u cos theta. It will be in I direction, and this will be in mu. Okay, I can write m here, na? Mu sine theta in j cap. We know that at the highest point only one velocity is available and it is unaffected. That will be mu cos theta. It is in cos theta. It will be in I cap. So my change in momentum will be equals to my final momentum minus initial momentum. Final is mu cos theta I cap. Initial is minus mu cos theta I cap minus mu sine theta j cap. Okay, cancel out. So my change in momentum came out to be minus mu sine theta in j cap. So if you want to write it as magnitude, so it is magnitude will be mu sine theta. Yes, beta. Done? Or you can do one more numerical, right? If a body it gets thrown with velocity u, and it gets struck the ground after time t with same velocity, what will be change in momentum? You can write that thing also. Okay, so by this numerical we are done with first law. First law completed. First law completed from 0 to 100%. Okay, number of topics covered. First law things. Second thing about force. Third thing about inertia. Fourth, momentum. So in this class we done these 4 topics. Okay, I think this is our first class. I do need to stretch it to 9:30, right? I will make it up to 12, 9:12. Okay, so but the next class will be of 90 minutes. Okay, I guess from this particular topic you don't have any doubts up to now, right? I am going with a good speed. I am giving you 100% content for your examination, whether you are preparing for your NEET, JEE or your board examinations. 1 week, एक हफ्ते में पूरा complete Sabha chat. In 1 week we will complete the whole lecture, right? But I will be not available to take the classes on Saturday. This one, due to the function at my home, I will not be available. So, but it will take, I guess, 6 to 7 lectures, because in NLM I am considering friction also. One week. Look, we done kinematics in 5 lecture, projectile in 5 lecture. NLM it will take around 6, I guess 6 lecture, right? Then we are having circular motion that will take 3 lectures. Then WP that will take around 5 lectures. Okay, look, I am giving you the things like I am teaching 11th one. I am not considering you people that you have done anything in your 11th. I am going with the basics. But I was in national players, right? So I guess you are not well aware of my experiences. I was right here, academic head. I was academic head in physics wala. Okay, I was plus educator at your an academy. I was educator at your Vedantu. Okay, so I left with these institutions, right? Which date? I guess it will go up to October, November, mid-December. I was teaching, na beta ji. I was affiliated with academics, with physics wala, academic head, then an academy, then Vedantu. It is not like मैं कहीं पे नहीं पढ़ाता that I am just taking you at YouTube, right? I am from these things. Okay, next week now what I will do now, I will just include one more page of my experiences. Okay, so let it be now. In next class we will be starting second law, impulse, rocket problems. This one is important. Okay, beta, how do you feel, Ria beta? How do you feel after attending the lecture? And third law. In tomorrow lecture we will be completing about these things. Okay, I will try to finish these things. Okay, how do you guys feel now after attending the class? Is this class useful or a bekar one? Okay, be honest now. Be honest with me. Yes, rocket propulsion, right? It is important, no? It is given in your NCRT and you will have a couple of numericals back in your PYQs. That's why I'm just taking these things here. Tomorrow we will be discussing these things. Okay, acha beta. Okay, okay, okay. And one more thing is that if you want 12th now, if you are English one now, if you are English student and if you want your 12th also completed, in English I just completed your 12th. But if you are English, tomorrow morning, that means 11 o'clock. 11 o'clock, I am having a lecture. You can attend that thing. Okay. If you want to attend the electrostatics from the basics for your examinations, you can attend the class 11 o'clock in the morning in the English language. हिंदी में हम वार्तालाप करेंगे. Okay. So I guess we are just done with today's class and you enjoyed today's session. If you are having any doubts or if you want to let me know anything about your preparation or if you need any mentorship, any guidance, you are most welcome. In the channel description part, you will find my Telegram link. Okay, you can write the Shukur Sir Physics. There you can just ask me your doubts, your things that you are in confused with. It's a trial mode, na? Look, I am just teaching English in the morning, just a trial base. If it gets successful, so I will just continue it at 11 o'clock. If not, then I will change it to evening one, then 10 o'clock, right? Evening one. Okay, I guess we are done with today's class. Thank you, beta. Thank you, bye. Thank you, thank you. Good night, beta. Thank you, bye, good night. You can ask me doubt, no issue. If I have any doubt regarding this class, you can ask me. There is no issue. Until then, I will save the PDFs now. But I am waiting for your doubt now. If you have any doubt, you're most welcome. If not, then bye. Take care. Okay, I guess you don't have any mood now to ask me anything. So you can do one thing now. You can come to my Telegram group. There you can ask me your doubts, right? RVSN problem. But what is RVSN problem? Good night, good night, beta. Ria. Good night, beta. Take care. What is RVSN problem? Okay, revision. Nah, I am not good with these short terms, right? So write everything. Nah, the revision ones. Okay. First of all, how you need to do revisions, right? Okay. So whatsoever your teacher is teaching you, you need to maintain a consistency regarding watching lectures offline or online. You need to make your own clean, very clean notes. Okay. And every day you need to take, let's suppose today we are doing NLM, right? But before that we are done with projectile motion and kinematics. You are thinking that no, I am not good with projectile and kinematics, what I can do now. Okay, first of all, do your kinematics from your teacher's notes, do your kinematics from your NCRT, do your kinematics from your NEET PYQs. After all these things, make a short notes, 1 page or 2 pages, right? So you will write each and everything, the shortcuts, the formula thing, each and everything to that particular page. Okay, so one chapter, 2 pages, nothing more than that. Now if you follow my short notes, my one chapter is in my 1 page, two chapter, 2 pages. So every day morning now you can take, I guess, 5 minutes it will take to revise your full chapter, and particularly on Sundays revise each and everything. Simple. Just like me, right? When I was just preparing for my examinations, I was just blindly follow my teacher. From after clearing my teacher doubt, then DPP, where I have modules, then my NCRT, then some books, then PYQ, short notes. Okay, on Sundays only I was revising each and everything in a very detailed thing. Rest days I was just studying, or I was just take a look towards the notes of short notes, 1 to 2 pages. That hardly will take five minutes. It is not feasible for us not to just revise each and everything on a daily basis. It will take a lot of time, and we don't have that much time, right? Do review like that. Take 1 page every day, or morning 1 page of your kinematics, 1 page of projectile, 1 page of NLM. Okay, you need to write an important points only, right? On rest days, what do you do? Do numericals. Take 1 hour slot for one chapter, 1 hour slot for different chapter. After increasing chapters, reduce the timings. Yes, beta, I am in the scheduling phase, right? Look, it takes time. It takes time. Look, what my plan is. First of all, but I will be completing your syllabus. That means basics of 11th and 12th in English and English. Then I am having planning of NCRT series. In NCRT series, I will be starting NCRT line by line by line, reading each and everything by line, so that you will have a trust on me, na, that I am teaching from NCRT only. Then I am going to start NCRT problems, solved plus unsolved. Third part, I will be solving most important 500 or 400 numerical per chapter. But it is a human nature, na. It is a human nature. So when we are preparing for anything, it is our human nature. We are thinking that no, I don't know anything, right? But in our subconscious mind, we know each and everything. You need to be in a fight for 2.5 years, right? You need to be in a fight. If you want to conquer the fight, you need to be very consistent, irrespective of your ups and downs. If you want to conquer the fight, your complete examination, you want to be in the fight. Okay, and each and everything you will get in this kind of particular lecture series, na. Don't worry, na. That's about you don't know anything about NLM, anything regarding kinematics and projectile, right? I am giving the content. You can compare my content, no. If I am giving you the content, you can compare my content. So come back to me. Okay, I am not taking any shortcuts, right? And do your work now by hard work, by loyalty. If you are loyal towards your dream now, if you are loyal towards what you want to achieve, right, you will achieve that thing. Definitely you will achieve that thing. And only doing numerical is not helpful. If you don't know the basics of numerical, if you don't know where I need to think and from where I need to apply the numericals way, right? If you know the basics of numericals, na, you will get your success. If you only know, no, I can do like this, right? It is not like that. You need to think about the core of physics. Why I am applying only this formula? Why not that one? Okay. So I guess we are done with today's class. If you have any other relevant doubts, you can ask me. Okay. I hope you are very good students and hardworking one. That's why I'm giving you the kind of answers. Okay. Be consistent regarding your studies. Be consistent whatsoever results you are getting, right? Do hard work, smart work, loyalty, and nothing more than that. And maintain your health. Thank you, beta. Bye. Take care. Bye, beta. Thank you. Bye.